So Charles Crouchman, I'm the CTO here at VMTurbo. I was, just for history, I was previous CTO at a couple other companies. One was called Opala Software in the runbook automation space. If you know System Center Orchestrator or Scorch, that's my baby. If you love it, I'll take the love. If you hate it, Microsoft did whatever they did to it after I stopped working on it. Application control. So why do we care about applications at VMTurbo? Well, there are a number of reasons. So first of all, what you'll find about our software and the way our analytics work is the more it learns, as you saw about this idea of the desired states as the intersection of a whole bunch of different desired states. Every time we learn more about the environment, we continue to refine our ability to determine that intersection point, right? We get smarter and smarter about finding the true desired state. And so adding a new domain like applications allows us to further refine that desired state, to find the perfect place where your infrastructure should be to satisfy application demand. Okay, so before we had the application control, we used VM demand as a proxy for application demand. And it turns out it's a pretty good proxy. If you look at the VM through the hypervisor layer and you look at the demand that's happening at the VM, it's a reasonable proxy for applications. For the application demand. But there are a couple of gaps. One of the gaps is there are certain pieces of middleware, certain application deployment platforms that do their own resource management and therefore make the resource allocation at the VM opaque. If you look at the VM, you don't get a true picture of what's happening from an application demand. So what we did was we pierced those. We outfitted those so that we can see the application demand inside the application, not just from the VM. Again, to help refine the idea of the desired state. The second thing is, as Eric alluded to, after we got really, really smart about matching infrastructure supply and application demand, we wanted to start talking about quality of service. We wanted to start to be able to make our analytics even smarter to say, if something is not meeting its quality of service definition, its SLA definition, how do we teach our analytics to give priority to that application so that it gets back on SLA? Stealing resources from other places if need be that are not behind on SLA or that are less critical workloads. How do we prioritize that application to be able to ensure that it makes its SLA or quality of service guarantee? Well, to do that, you have to get to application metrics. You can't do that based on resource utilization metrics at the VM. And then the third problem that we looked to solve finally was, if our goal is to assure the performance of applications while utilizing the infrastructure as efficiently as possible, well, to assure the application of the performance of applications, you have to look across multiple tiers. Sometimes the bottleneck is in the physical host, sometimes it's at the VM. If your VM isn't configured correctly, you could have as much host capacity as you want. You're still not going to get performance. Sometimes the bottleneck is in the application tier. Now, if it's in the code, we're going to excuse ourselves from that. But if it's in the configuration of the deployment platform or the middleware component, we're going to add that to our problem domain. Okay. And so what this is showing here is really a list of both our currently supported as well as our intended platforms to support. So you may have seen this before if you know anything about VMTurbo. This is what we call the supply chain or our abstraction model. Once we discover everything in the data center, we map it to this abstraction model to simplify the problem of understanding everything in the data center. We then understand the flow of resources between all of these things, and then our analytics, our algorithms use pricing to determine how to make our recommendations in our automation. But the important thing to note is all we really had to do here was add another tier up at the top, that application tier, to our existing supply chain, wire it up to the VM to understand the flow of resources between applications and the underlying VM, and our core economic scheduling engine, our analytics engine, knows how to deal with that right out of the gate. We just have to add a new type to our data model. So I'll tell you what platforms we support. Everything is agentless because we're not trying to determine the number of times a method is called, or we're not trying to find bad SQL queries. We're focusing on the configuration of the middleware tier itself. Everything is agentless, JMX for application servers, JDBC for databases, for example. No agents whatsoever. We leave application code profiling to the APM tools. That does require agents. You have to be inside the runtime. We don't have to be inside the runtime. So which applications? So we started with Java application servers. Again, for the reason that these are the sorts of application deployment platforms or middleware components that do their own resource management and make looking at resources from the VM opaque. It does its own heap management, so looking at memory at the VM is not good enough, for example. So we support all the major Java application server platforms. We then released SQL database support, Microsoft apps, and we'll be working on NoSQL in an upcoming release. We have plans to go beyond that as well. This is just what's released and sort of what's in the committed roadmap or under development. So what we call commodities are the resources that are traded in the supply chain, the things that we look at in order to make the recommendations and run the automation that we do. So if you look at the Java application servers, we're looking at, from a resource perspective, we're looking at things like heap, which is a proxy for memory. We're looking at connection pools, JDBC connection pools, which is a proxy for I/O at the application server. We're looking at thread pools, which is sort of like a proxy for CPU, right, or throughput of the application at the application server. We're looking at garbage collection because that helps us to do a better job of understanding and recommending heap sizing allocations. And then from a quality of service perspective, from an SLA perspective, we look at transactions and response time. Okay, and I'll show you that, and I'll go into more detail in that when I get to the demo, when we get off the slides. From a SQL database perspective, database memory, again, if a database does its own memory management, if you look at it from the VM, its active memory is 100% all the time. So we look at, we pierce the database memory and we understand how the database memory is actually being used inside the database. Connections as well, and transaction logs as a proxy for disk space. More to come there, by the way. And then again, from a quality of service perspective, transactions and response time. So what is it that we do? First of all, defining performance. So we look at transactions and response time. We allow you, the user, to set quality of service targets or SLAs against them. And then whether you're in or outside of compliance on those, we'll then alter our analytics to as I mentioned, to give priority resource access to the applications that are not meeting their SLAs, to allow you to start to now guarantee SLAs by ensuring that resource allocation priority is given to those applications.
Now, do those SLAs work on a schedule? Like if I have a system, like say my accounting system, 3 weeks out of the month, it gets about 50% utilization. That last week it's month-end close and it's getting hammered with data entry and reports. So can I say, during the last week of the month, this is the SLA, but for the rest of the time, it's at a lower tier?
So what happens in that scenario is your utilization fluctuates, but your SLA really is always the same. If your SLA is defined as, I want the response time for this application to always be less than a second. And for most of the month, when it's not busy, that'll have absolutely no effect on our system. But when demand spikes, we'll start to give priority to that thing. So you don't have to change the SLA definition, even though utilization is fluctuating. Okay. And then the other thing, as I mentioned, we want to better understand the demand of the application by piercing the application layer, so that we can look at resource utilization inside the application, not just from the VM. And then controlling applications, back up into the applications. Because we understand the infrastructure supply, we can do a pretty good job of helping you to configure the application tier. One of the biggest problems that I find going out and looking at performance issues in customer environments, you might have a couple of applications where you've tuned the heck out of them, right? Where you've looked at how the application actually consumes memory and you've tuned the Java heap specifically to that. But the vast majority of them are deployed with defaults or templated configuration. That is completely divorced from two things: how the underlying infrastructure is configured, which by the way is in flux all the time, and the actual demand on that application. So what our software does is understands both of those things. What's the actual demand on the application, and what is the available set of resources in my infrastructure, and therefore how should my application tier be optimally configured in the context of those two things, which is much better than deploying from defaults. Okay? Service level assurance. So you define the quality of service. I think I preempted this. You define the quality of service at the application tier. What that does, the way that works in our analytics engine is it causes that application, when it's outside of SLA, to generate more revenue, more buying power inside of the financial market, which is how our analytics work. It gives it more revenue, therefore it can afford to buy more expensive resources, right? And if somebody else who has less revenue, meaning he's not as highly utilized and or he's not outside of his SLA, has less revenue, in a resource contention scenario, the one with more money wins. Because the price of the resource goes higher and higher and higher until I can afford it and you can't. That's kind of how it works underneath, without going into a whole lot of detail about how our analytics work.
Sorry. Do you support tiered application in this model?
Sorry, which application?
Tiered application.
Yes. So the SLA is defined at the, well, you can do it one of two ways. You can either do it at the individual tier. So let's say I've got a multi-tier application. I can do a response time SLA at the database itself and at the application server directly. Or alternatively, what I really care about is the end user experience, I can just do it at the top of the tier, and then VMTurbo will take care of managing all of the intermediate tiers. So if I just define the transaction response time at the web tier, then the rest of it, you don't care what the database response time is. You really just want to optimize the end user experience.
Shouldn't there be a link somewhere where you link the application to that specific database instance?
Exactly right.
Okay.
And we do.
Okay.
Yes.
One question came up, Charles, from Nick Collier on the internet. Oh yeah, you're going to catch this one. And he talked about, can we use the REST API in order to create policies?
Yes.
So, and that was, and I wanted to make sure that we covered
Yes.
that.
I'm looking at Andrew for his nod. He's the REST API guru, but generally speaking, anything you can do in our UI, you can also do via the REST API.
And any integration for vRealize operation, vRealize automation?
Yes.
So already pre-built, or we're going to need to develop that integration into the API ourselves?
Well, it's a very simple, straightforward integration to any self-service provisioning capability, whether it's vRealize or whether it's OpenStack portals or CloudForms or whatever you've got.
So at this stage, you provide the API, and it's up to the customer to integrate their chosen automation.
Yeah, today I think it's a simple API-based integration. Correct. It does require a small script, small scripted integration. Okay, I'm not going to dig too deeply into the quality of service definition there. So what I'm going to do is I'm going to move to the demo. If you could flip me over, please. I'd rather show it to you than explain it to you. Okay. That's Endra's. I need mine. Yep. All right. Fantastic. Okay. All right. So what you're seeing here is, again, our supply chain, which is our abstraction for the data center. In this view, there are a couple of different views. There are different ways to look at what it is VMTurbo is telling you. Just really briefly, if I go to the dashboard view here, this is a view of my global environment. And what I care about, again, what I care about in VMTurbo, I don't care about looking at utilization charts. I don't even care about looking at alerts. What I care about is VMTurbo giving me recommendations about specific recommendation on how to remediate something in my environment. So I'm going to look up here to see, is VMTurbo telling me there's anything to do? And this is a summary of all the recommendations in the environment. This is a development environment, so it's pretty straightforward. I can also look in my supply chain, and now I can start to understand how these things relate to each other. I can understand which applications are on which virtual machines, which are on which physical servers, which are attached to which storage, and so on and so forth. So what I'm going to do here is I'm going to look. I see I've got an application in the red. This is a WebSphere application server. And again, I can look down here and I can look at the utilization and I can see that it's spiking. That's all fine and good, but what matters is that VMTurbo is actually telling me what it is that's wrong with my application and what needs to be fixed. In this case, I need to increase my JDBC connection pool. I've flooded my JDBC connection pool, so I need to increase that. Okay? The other way you can look at the data inside of VMTurbo is through the inventory tab, and we've got a specific application view here. So I can look and I can see here are all the Oracle databases that have been discovered by VMTurbo in my environment. Here are all the SQL Server databases, all the WebLogic servers, all the WebSphere servers in my environment. And again, these are just the ones in my environment. It could be JBoss servers, they could be MySQL databases, so on and so forth. And again, I can look at that same application server from here and see the same recommendation, the same utilization charts. But I can look now at the specific resources or commodities that we've been measuring. So you can see here for this application server, you can see exactly what the heap utilization is. You can see that there's not excessive garbage collection going on. I've got 0% time spent in garbage collection, my thread allocation, and so on. Now, quality of service. What I do is I go over here to the policy tab. Under analysis, application. This is our scope view in the middle, so this allows me to select a particular application or set of applications based on any kind of criteria you want to use to slice and dice it. I'm just going to choose a general group here. And now what I can do is I can set a response time SLA. So I can select this and set in milliseconds what I want the response time to be for transactions at all of my WebLogic servers, because in this case I chose all of WebLogic. I could choose a specific WebLogic server, get down to a particular application. All right.
So do you get an alert, or it tells you how to fix it, but there's no, it's not like the right sizing where, hey, I can do this for you. You
Right.
still have to go in and fix it yourself.
Well, so what happens in this case now is nothing changes. VMTurbo is going to continue doing everything that it always did, but if you go outside of that SLA, it's going to give priority to that particular application.
Okay.
From user experience, you're going to see nothing different other than you'll see potentially more recommendations for that application because he's overriding the other folks. From an automation perspective, it's just like everything else. You can either run it so that we generate recommendations and you action them manually. You can turn it on to automated and let VMTurbo just run and automate them for you. You can schedule them to run during a change control window, or you can send them out to a change control system where they'll wait for approval.
Nice.
Any or all of the above.
Speaking of automation, what sort of APIs or integration do you guys have with like Orchestrator and things like that? And
Yeah, so there's two. We've actually, if you go to our community, the green circle, you'll see a post there on how to integrate VMTurbo with System Center Orchestrator. So generally speaking,
or how about VMware vRealize?
or VMware vRealize Orchestrator, it's the exact same method. It's just you just replace the Scorch API with the VMware Orchestrator API. Yeah. So generally speaking, API-based integrations. Some of them so anything that we discover, manage, and automate all comes right out of the box. Integration with your enterprise tool set, API-based integration, is generally something done post-install based on your particular set of tools and configurations. And there are all kinds of examples on how to get that done, or you can use our services to get it done for you.
One other thing I thought of, one of your slides back showed org and provider VDCs. You guys, clearly that's a vCloud Director construct or whatever. Are you guys doing anything that follows the tenant models of like vRealize automation or anything like that, where this could actually be a multi-tenant sort of thing? Where
Yep. Andrew, do you want to take that one?
Sure. So we actually map tenants to VDCs the same way as we map organization VDCs to VDCs in our model. We actually might have visualized some of those things as org VDCs in our abstraction. we actually represent it as a VDC regardless of where it's coming from. So tenant gets mapped from each cloud management tools that we are controlling, CloudStack and OpenStack, into the same VDC concept. And we actually build a supply chain of how the VMs that belong to that particular tenant consume resources from that VDC, how that VDC's resource allocation is being managed, and how that VDC or how that tenant is consuming resources from your underlying physical infrastructure. And we end up controlling not just the VM's resource allocation to how they use it from the infrastructure, but also the resource allocation for the VDC, or for the tenant in this case, on how it should be sized to be able to serve the VMs in the context of what infrastructure you have to provide resources for it.
Cool. Thanks.
Okay.
What happens if you set an SLA that's just not obtainable?
Yeah, so what we can do is, again, give priority to that, priority access to resources for that application. If once it's got all the resources that it's asking for, if it's still not meeting that SLA, there's nothing more we can do. So this can't kind of go awry and start to cause havoc in your environment. We'll just make sure it's got all the resources it's asking for, and then we'll stop. One last thing I wanted to show you, if I could. So again, the beauty of our supply chain. So I started here, I looked at this particular application server, and I can see this got a problem. I love to be able to trace everything all the way from the transaction to the metal. So I can look at the transaction coming in at the application server. I can look then at the virtual machine on which that application resides. I can also see what other applications are on that same virtual machine in case there's interference between applications at the VM level. I can drill further now to see which physical machine that virtual machine is on. And again, I can see all the virtual machines now on that physical machine to see whether they're interfering with each other. And I can keep going. I can go all the way down to the storage if I've got the storage control module installed.